This session is a discussion on Ontario's role in 21st century mining. And before I introduce our moderator, I'd like to make a special announcement that we have for a new funding opportunity for those in the mining industry, but also for those who are not in the mining industry to take advantage of. And before I make that announcement, I'd actually like to invite some of the partners who have gotten together on this to make this all possible. Sandy Reid is with NSERC Ontario. If you can just step up with us. She is the Research and Innovation Development Officer at NSERC Ontario office. Douglas Morrison, who is going to be moderating our panel today, is the President and CEO of the Centre for Excellence in Mining Innovation, otherwise known as CEMI. So you might hear the term CEMI used over and over, but that's the Centre of Excellence for Mining Innovation. And of course, OCE, and Douglas's partner, Jane DeVray, Director of Business Development, if you can join us up front as well. The announcement we'd like to make is that between the three organizations, OCE, CEMI, and NSERC, we've developed a program to fund up to $3 million worth of research in mining and mining-related sectors, and I'll go to a little bit more detail in a moment, to do research at universities. And in fact, some of that money might actually be able to flow to companies that are participating in the industry-directed research that will be funded at universities. So a very exciting opportunity, up to $3 million in funding, and it is essentially to fund productivity improvements as it relates to the mining industry or related industries. So imagine the upstream and downstream from the mine pit itself. Energy related to mining, water related to mining, and waste related to mining. A couple of examples. We dig a lot of stuff out of the ground. 99 kilos of every 100 kilos ends up as waste. And there's actually a big issue with what do we do with that waste. Is there more value that can be extracted from it? Or can we put it somewhere else that's more useful than just sticking it in huge piles? So there's a number of issues around the waste created by mining. There's also a number of issues created by the water needed by the mining industry. Where do we get it from? What do we do with it? And what do we do once we've done what we do with it? And there's a whole bunch of issues around water for the mining industry. Likewise in energy, a lot of the mining locations are not right next to Bruce power stations, so power is a very important element in the industry, and we need to generate power, we need to conserve power, and maybe we need to reuse power in some way as well. So there's opportunities in all those areas. Think about the mining industry, about all the supply chain that supports the mining industry. We're interested in projects that will support that supply chain as well. And in particular with this initiative, we're looking for different approaches. We're looking for other industries that are not in mining. We're looking for researchers that are not mining researchers to bring new ideas to the table to help solve these problems. Now, we plan to have a forum in June in Toronto, and anybody here who wishes to join the forum can leave any of us up here their business cards, and we'll make sure you get invited to that forum where you'll learn more about what the industry issues are, how the program is going to work, how it will be funded, and what your chances of success would be should you put in an expression of interest to try and take advantage of this $3 million in funding. So very exciting time ahead for the next year in our funding of $3 million in mining. So have I missed anything out, Jane, that I should talk about further? I got it all covered. Great. Douglas, have I got everything? Great. So thank you for your attention on that. And now we'll move back into the session here. And I'd like to introduce Douglas Morrison. He's kindly agreed to be our moderator today. He has 30 years of mining experience, about half in operations and half as a consultant in the industry. Throughout his career, he's maintained advisory or board roles with Canadian research organizations such as Camiro and Mirarco, which are engaged in delivering innovation to the mining industry. Again, Douglas, welcome to the session, and thank you for moderating. So I'll hand it over to you. We're going to take a group photo. Thanks, Doug.
Okay. Thank you, Ross. I'm delighted to see you all here this afternoon. We have 4 very distinguished panelists. We'll start with Christine Kaszycki, who's now with the Secretariat of the Ring of Fire in the far north of Ontario. She started her career. Christine, yeah, if you would like to come up. Christine started her professional career as a geologist in Ontario with the Ontario Geological Survey. In 1997, she moved to Manitoba, where she took on a responsibility as the Assistant Deputy Minister, looking after and developing relationships with First Nations and Métis communities. And in 1997, she came back to Ontario. From 2005 on, again as ADM in the Ontario Public Service, and in 2010 became the Secretariat for the Ring of Fire in Northern Ontario. Our second panelist is Brian Buss, who, like me, has 30 years' experience in mine operations. He's the Vice President of Development for Lakeshore Gold in Timmins in Northern Ontario. Our third contestant, our third panelist, is Ramesh Subramanian, who's the Director of the Barty School of Engineering at Laurentian University. He started off his career with a PhD from New Brunswick, and then spent some time at Wisconsin-Madison, and then also at McMaster, before joining Laurentian University, where he's now the Director of the School of Engineering. Ramesh. And then finally, Dr. Dean Miller, who completed a PhD at Imperial School of Mines in London, and then continued as a teacher there, also worked at Camborne School of Mines and the Technical University of Delft, and he continues to be a visiting honorary professor at Camborne School of Mines for the University of Exeter. And he joined us 2 years ago in Mirarco, where he's now the Director of the Energy, Renewables and Carbon Management Division of Mirarco. Dean, thank you. So the question is, why are we actually here? What are the signs? Is this moving on or not? That's got to go backwards. So that's who we are. This is the Centre of Excellence for Mining Innovation. We're a relatively small group that tries to bridge the gap between industry, researchers, and funding agencies to get more innovation delivered to the mining industry. Why is mining important? Many people in Southern Ontario, in a post-industrial society like that in Toronto, think that mining is not important at all. People think, why would we do that? Is it not a sunset industry? Is there really any value in doing that any longer? Everything that's of value to you in your life in the 21st century comes from mining. Without mining, there are no high-rise buildings, there are no cars, there's no oil industry because there's no steel for drill steels and drills and oil rigs and refineries. In the medical business, there are no high-grade alloys for scalpels. There are no MRIs. None of those things exist without our industry. Now, most of what we do is on a very, very large scale and not highly refined things, but nevertheless, the core work of what our industry does has to be done, and it has to change significantly in the 21st century. CEMI was established to go through 5 themes: exploration, deep mining. The problems of deep mining are essentially rock stress, because the mines in Northern Ontario are over 2 kilometres deep, and at that depth they generate their own earthquakes. Not small earthquakes, not huge earthquakes like the one you recognize on surface, but small earthquakes 20 meters away is a significant earthquake. It may not be a Richter 8, 5 kilometers below surface, but 20 meters away, any earthquake is a bad earthquake. So earthquakes are one issue, and heat. As we get deeper, the mines get hotter and hotter, and we have to manage that heat. That's the biggest reason for the big fans that we use in mines. If you think of a fan that you might buy in any store for a normal surface operation, our fans look like the biggest aircraft engine you have ever seen. It's a turbine that works 24 hours a day, 365 days, pushing air through mines in order to keep them cool. Those are some of the issues that we deal with in deep mines. In value mine, we're looking at optimization of production logistics, manpower, machines, equipment, and how we make that more efficient and more productive than it has been in the past. Underground construction, that's a project driven primarily by one of our major sponsors, Rio Tinto, to adopt tunnel boring equipment into the underground operations. So we drive tunnels faster and we drive shafts faster than we have done in the past. And finally, sustainability and environmental issues, which are crucially important for the management of wastewater, and how we help communities that live close to mines to continue with an economically viable society after the mine closes. So post-closure sustainability is important for local communities close to mining centres. So those are the 5 things we were set up to do. We look at the mines in Northern Ontario, whether it's the mines or the tailings ponds or the geological resources that we have, as living laboratories where we can conduct experiments on how to improve things. So the mines are not just operating facilities, they actually act as a laboratory where we try out new pieces of equipment, new ways of doing things, and that's a major asset that we have in the far north of Ontario. We're also engaged with a broad range of people in the service and supply industry, as well as academia, and with companies outside the mining industry to try and bring in technology from other industries to help our industry become more cost effective. And the main reason for doing all this is 3 things. Number 1, to open up new mines and speed up the development of existing mines, to extract more value from the mines, to mine deeper. Underground mines will progressively get deeper and deeper. Reduce the energy consumption of those mines. Although the ventilation cost goes up, we have to arrange things so that the total cost of the operation goes down because of the demands on our operations. And finally, we want to increase the value that's extracted from the material that we bring to surface. If we're hauling material 2 kilometers from underground to surface, we want to maximize the value that's generated from that material and minimize the environmental impact that it has either on the land, on the air through smelting, and on the water resources that surround the mining communities. That's our purpose. That's where CEMI sits. You might think that academics can do this work by themselves, or industry can do that work by themselves, or the service sector can do that by itself. But they all have primary responsibilities, primary objectives, and none of those are actually directly focused on innovation. What CEMI does is we focus our entire attention on innovation and work with those other groups to help pull those things together and make innovation happen. The difference between innovation and research is implementation. You can have a research project, but if it doesn't get implemented into routine operations, no innovation actually happened. So the implementation of new ideas and new processes and new techniques is crucially important, and that is actually the hardest thing to do. Many of you people engaged in research think that the difficult piece is the research piece. In actual fact, once you have the answer, getting other people to accept the solution and implement it into operation is the biggest step that we have to overcome. So yes, the mining industry is not a friendly industry for new ideas. It's a very robust industry. But in actual fact, one of the benefits that we have is the demographics will be helping us to change that picture very, very soon. This is one of the techniques that we're developing with Rio Tinto. We're helping them with the rock mechanics of how to make this tunneling technique work in these deep underground mines where they will be subjected to very significant rock bursting and seismic activity. Not a trivial problem to solve. That's the globe. It doesn't show very well on the screen, I think, but that's the globe, and we think that the global mining industry is very equitable the way it works around the world. In actual fact, that's not the case. The world actually isn't set up to look like all these countries with their own colors and their own borderlines. This is the better picture of the way and how it's actually worked. Now you can see where the concentration of light is on the planet. That's the concentration of middle-class people that the mining industry has to serve primarily. So we have 1 billion people in Western Europe and North America, essentially. That's the highest concentration of middle-class people that we have. And up until now, the global mining industry has been serving the needs of that 1 billion people primarily. What happens now is we now have to supply the needs of the other 2 billion people who want the same resources in India and China and Southeast Asia, which means that the global mining industry in the next 20 to 30 years has to triple the amount of material that is produced. Triple the amount of material produced to meet the demands of the global middle class of 3 billion people. And we have to do that from these kinds of places. These is where the natural resources exist that will supply the needs of those populations. That's where the resources exist, and that's where they have to shift to. The other big problem we have, well, the biggest product that we move is iron ore and coal for steel. Even if we stop burning coal tomorrow morning, we would still have to mine coal in order to service the steel industry. Steel is made from iron ore and coking coal. So there is no possibility of not mining coal on planet Earth. It has to be done to meet the needs of the steel industry first of all. But steel is just basic steel. You can make railways and basic pieces of equipment with steel, but not much else. If you want to have a sophisticated economy, you have to have all these other metals. So the global mining industry has to triple its output at a time when we've already had peak copper, peak nickel, peak zinc and lead and chrome and molybdenum. All these metals go in to make a variety of alloys in the steel that are used for a whole variety of different products. These smaller metals are crucially important to the functioning of the global economy in the 21st century. There's lots of coal, lots of iron ore, but these other metals are crucially important. And we have to triple the supply of material to meet all the needs of 3 billion middle-class people in the next 20 to 30 years. And we have to do that with a demographic where the average age of the workforce in the global mining industry is 55 plus. That's the transition that has to happen, and it has to happen for everybody to receive the material that they need for that economy, for the global economy. Now, many of the people in this industry now, as I say, are not particularly open to new ideas and new ways of doing things, but they will be leaving our industry in the next 10 years. And what we're looking for is the new generation of people that have to come and help us drive that industry forward with all the new techniques and all the new ideas that will make it successful in the future. That's why we're here, to try and attract as many scientists and engineers and technologists as we can to work for this industry and help us ensure that all of the populations that demand the metals that they want actually get what they want. When segments of the global economy don't get the material that they want, large numbers of people become very unhappy and bad things begin to happen. So we're in the business of trying to make sure that everybody gets what they want, and we'd like as many young, educated professionals to come and help us. Some people will say, well, we don't really want to work in an industry that looks like this. If I have to dress this way, it doesn't look very sophisticated. Yes, the mines are very hot, the mines are very deep. Mines are 2.5 kilometers below surface now. They will get deeper and very, very hot. But in actual fact, in the future, very, very few people underground will look like this. Most of them will look like this. So it's not exactly the suit we'll be wearing, but it'll be something very, very similar to the Gemini suits that we have 50 years ago for the space agency. We're in the business of bringing space technology into mining. Many of you might well have heard about going to space to mine asteroids, etc. In the context of what the global mining industry has to accomplish on planet Earth, mining asteroids is completely irrelevant. There's just no way you can produce anything like the scale of material that's required. So it may be interesting and sexy, certainly more sexy than what we really do in the mining industry, but if you want to make a real contribution to how things will actually be in the next 30 years, working for the real mining industry is the place to do that. And it's not just in operations, it's how we manage the environment, how we find deposits, how we extract them, how we set up the infrastructure to bring those materials to market from very remote parts of the world. All of those things have to be done, and they have to be done by a completely new generation of people, many of whom are here, and we'd like to think will actually start to come and join us. Why is Ontario the best place to do this? It's really the best because in Southern Ontario we have one of the highest concentrations of intellectual capability anywhere in the world. These are some of the universities that we're working with already. We're trying to bring the intellectual capacity that exists in those universities through Sudbury to help service the mining industry and where it exists now. That's what we have to do. There's even more intellectual capability in Southern Ontario here than we currently access, but it's a high concentration. Just as we have a high concentration of resources in the north, we have a high concentration of intellectual capability in the south. However, you have to bear in mind that that's not the entire province. That's the province. That's the province. And that's where the resources are. That's where the resources are in the next 20 to 30 to 40 years that we can access and will have to access. But we can't do it with the intellectual capacity that exists in Northern Ontario. We have to draw on the intellectual capacity of the entirety of the province, and in fact, the entirety of the country as a whole. As we do this for Ontario, as we solve the problems that we have to solve to extract the metals in Northern Ontario, we also help the mining industry to solve the problems that exist throughout of the far north, across the Northern Hemisphere and the Southern Hemisphere. And in actual fact, by doing that, we actually solve the problems of the global mining industry, whether it's in Northern Ontario or in South America or in Africa. The problems of remote operations of large-scale infrastructure to bring material to market, whether it's in Northern Ontario, whether it's in Africa, are the same. We tend to think that Northern Ontario or Northern Canada is a wet place because there's lots of lakes, but it's not as wet as we think. We have water issues to address, just as they have water issues to address in the arid parts of the world. So the solutions that we develop in Ontario actually make Ontario the source of all the information that the global mining industry needs to extract all the material that we need to meet the needs of the global economy in the next 20 to 30 years. That's what makes Ontario crucial. That's what makes the intellectual capacity in Southern Ontario a perfect match with the resource capacity in Northern Ontario. That's what will turn Ontario into the knowledge economy for the global mining industry, and that's what we hope to accomplish. So with that, I'll ask the next of our panelists to come up. Christine is going to talk about the far north. You can see where the far north is. I'm sure Christine has another map. Is that good enough, or do you have another one?
Oh, I've got lots.
You've got one. There you go.
Thank you.
Just press the big green button.
Big green one? Okay. Well, thank you very much, Doug. That was a fascinating overview of the kinds of challenges and opportunities that are presented by the mining sector in the go forward. What I'm going to speak about today is a particular opportunity that's, it fits right within that 20 to 30 year timeline that Doug was speaking about in terms of future resources and resource development. This presentation focuses on an opportunity in Ontario, in the far north of Ontario, which has been termed the Ring of Fire. That was not our terminology. That was a Johnny Cash fan explorationist who identified that moniker, but it certainly has stuck, and it's got quite a bit of cachet associated with it, so I think we'll live with that for a while now. So as we move forward here, I'm going to give a brief overview of what the Ring of Fire is, where we're at in terms of the project itself, and then some of the key considerations as we move forward. Okay. So the Ring of Fire in and of itself, because of the scope of different mineral discoveries that have happened up there over the last decade or so, has the potential to be one of the most significant mineral development opportunities in Ontario in quite some time. The scale of mineral production could be on par with the kinds of production that we've seen out of Sudbury, Red Lake, Timmins, etc. But what this does do is provide us with an opportunity to think strategically, get ahead of the development itself, and think more broadly about the full range of opportunities and approaches that development of this nature can present. And that includes not just mining and infrastructure development, but also value-added manufacturing, some of the partnerships and social innovation required to ensure that our First Nations communities are full partners in this development moving forward. And doing this in the context of our far north land use planning legislation that requires communities to actually undertake land use planning so that planning decisions and development decisions can be informed in the broader scope of community interests. So the particular scope of the Ring of Fire in terms of the benefits, right now there are 2 projects that are moving forward with respect to potential developments. One of them is a Cliffs Natural Resources project. They're looking at developing a chromite mining operation within the region. They're projecting on the particular deposit that they're moving forward with right now about a 30-year mine life for that particular project. There are 2 or 3 additional chromite deposits that are very similar in nature. So if these are all developed sequentially, it has the potential to be a very long-lived opportunity in this region. The investment alone is more than $3 billion in terms of the commitment to building the mine, transportation facility, and processing facility. And it would include about 1,200 direct jobs within the region, and a few thousand more direct or indirect and induced jobs. The Noront Project is the second one that's moving forward in the area, and this is a nickel mine. And again, they're projecting about a $730 million capital investment and about 700 jobs during construction and 300 ongoing jobs. So just those 2 projects alone are generating significant economic opportunity, not just for the north in and of itself, but in particular for remote communities in an undeveloped area, as well as Northern Ontario and Ontario as a whole. So just a little bit, it's unfortunate you can't really see these very well, but the Ring of Fire is this red arcuate series of claims as presented here, located right in the central portion of Ontario's far north. As I said, several significant new mineral discoveries, including copper, zinc, nickel, platinum group elements, chromium, gold. One of the biggest challenges in this region, aside from lack of access, there is no existing infrastructure in the area. The communities within that region are fly-in only or winter road access. So infrastructure development is a key aspect of moving this project forward. One of the other challenges is that it's a very wet area on the edge of the Hudson Bay lowlands. So some of the issues that Doug was speaking to earlier around water management and innovative approaches to waste management will be critical as these projects move forward. And in addition, there's no existing power within the region. Right now, the company proposals are to use tried and true technologies in terms of diesel generation, but I think there's lots of scope for innovative approaches in terms of power generation within the region. Just to put this in a Southern Ontario context, we've just placed the Ring of Fire in Southern Ontario, and you can see that it extends basically from Toronto north to Barrie and about halfway between Toronto and Kingston. There's quite a number of claims that have been staked in the area. There's about 35 different companies that are exploring. Most of the intense exploration is in a relatively small area that's included within the oval that you see there, and that's where most of the chromite and nickel is. And then just zooming in on that oval, you can see the series of discoveries that have been made in that area. The red dots are the chromite discoveries. The blue dots in the southwest are the nickel discoveries. The deposits with the green circles are the two that are moving forward with development proposals, and they're about 7 or 8 kilometers apart. So in this large area of about 4,000 to 5,000 square kilometers, there are 2 mines that are basically being proposed for development in the same place. Still at a relatively early stage in the process, although I think this star will begin to move forward relatively quickly. Companies are proceeding with their environmental assessments right now, moving into feasibility or completing feasibility projects, and one would expect over the next year or two that development decisions would be made. And what's driving this opportunity? I've talked about chromite and nickel. Doug referenced the demand for commodities that produce steel. In this particular case, stainless steel. Both chromite and nickel are key elements in the production of stainless steel. And development in China, India, the BRIC countries basically are driving the demand response. So I would just focus a little bit on a recent announcement that was made last week. Cliffs Natural Resources announced that they are moving to feasibility on their chromite project. They identified there was enough certainty in discussions to commit to a processing facility in Ontario, and they have identified for the first time in a couple of decades a new processing facility will be developed just north of Sudbury. Ontario likewise announced as part of this that they were committing to support investment in transportation infrastructure, although these would all be subject to environmental assessment approvals, Aboriginal consultation, etc. But I think very importantly, Ontario also announced a suite of commitments to First Nations that relate to the various things that we've heard from communities in that region over the last several months. And these are focused on regional environmental monitoring. Because this is a pristine area that's not been developed before, communities are quite concerned about potential impacts, not just of these 2 developments, but what are the cumulative approaches or the cumulative impacts for future developments or future uses within the region. A process for regional infrastructure planning. Much of the discussion to date has been about roads to mines or infrastructure to mines, but as development within the region moves forward, there'll be a focus on local access, communities interested in becoming part of the transmission grid, and also enhancing community-based infrastructure so that communities actually have an opportunity to engage in business development and improve socioeconomic conditions. And lastly, a commitment not just for social supports, including health care and skills training and development. These are critical to ensure that First Nations communities are prepared to be able to participate in these developments, but also to resource revenue sharing so that communities benefit directly from developments within their region. So the current status on these projects, as I've mentioned, both are proceeding through EA right now. The Cliffs Chromite project, their base case for investment planning is an open pit mine and a concentrator in the far north, and an all-weather road north-south from the mine sites to Nakina to a site near the CN rail line. I'll show you a map in a second, and a processing facility north of Cape Real. The total capital investment is about $3.3 billion. Noront Resources, on the other hand, is looking at an underground mine, and given the challenges in terms of water management and their interest in reducing the surface footprint of their mining operations, are proposing to establish their concentrator for processing underground, as well as store all their tailings underground. So these are innovative approaches to reducing the environmental footprint and helping to manage impact on water within the region. I'll just focus for a second on, well, it's unfortunate that this didn't copy very well, but I'll just focus a little bit on the First Nations communities within the area. Am I out of time? Okay. So I guess it's a good thing that the slides aren't showing up very well because I'm out of time. So I'll just summarize by saying that the developments in this region present huge opportunities for socioeconomic development, both within the far north of Ontario, but also across Ontario as a whole. They also provide unique challenges that will, I think, help to drive innovation in mining technologies, certainly from an environmental management perspective, as well as drive new approaches to working with First Nations communities in terms of various delivery of various types of social supports. In general, I think it is really a transformative project for far north of Ontario, and looking forward to moving this through to the next stage. Thank you.
All right, good afternoon. Thank you very much, Doug and the panel, for inviting me along to represent industry at this talk today. I will be presenting a few slides on the application of innovation and human capital as something that is imperative to the mining business. I will be coming at this from a purely business point of view, and I certainly hope that I don't present things that are too simplistic or too blunt, but sometimes that is how business functions. So as was mentioned, with agriculture, mining is one of the two core businesses or industries on the planet. Our industry is based on exploitation of non-renewable resources, and this is absolutely fundamental to understanding the context around mining. There is a life cycle for every project. We've heard some interesting discussion on the Ring of Fire. It will follow the same life cycle as a small quarry in southern Ontario. It will be discovered, it will be developed, it will operate, and eventually it will close. And this is quite key to the way we go about fundraising and financing mining projects. We are brutally subject to the laws of supply and demand. There's no escaping it. Every day there is a mine opening because the economic conditions are right, and there are mines closing because the economic conditions are right. And capacity will be added and subtracted as markets fluctuate. This creates a cyclic nature in the industry which can't be denied, which is further complicated by the length of time that is required to develop mines and bring them into production. And this is a significant challenge for the industry. As a result, the industry is always mining the next best ore body. We are essentially always working at margin. And this is really where the technical challenges need to be overcome, to preserve and protect margin. A little bit more context. Cost pressure is absolutely tremendous, both in terms of capital expenditures up front and operating expenditures ongoing. We are under a deserved and continual scrutiny to be socially responsible. Track record of mining has not been stellar. Thousands of years of mining have come and gone. Hopefully many more, hundreds at least, are ahead of us. But we do need to hold up our end of the deal in terms of social responsibility. Our shareholders are brutally frank with us, and they demand returns. Essentially, we're driven by business metrics. We do, obviously, we do our best to comply with all the demands that are being placed upon us from our stakeholders. But at the bottom line, this is all about net present value. It's all about cash flow. It's all about turning a profit. So I'd like to introduce a bit of a graphic here. The final comment, those that can make margin will survive and those that can't won't. So it's strictly business economics. I'm going to throw up a bit of a graphic here, talk basic principles here. I hope I don't insult the finance people in the audience. But essentially this is what a mining project looks like to a financier. Along the bottom is time. You'll see it takes a long time to develop projects. It costs a lot of money. The bars represent annual cash flow. On this graph, it's interesting to look at what you don't see. You don't see safety statistics. You don't see environmental compliance statistics. You don't see number of people employed. What you see is time and money. And that is what drives the decisions. And it's not to say that those other issues aren't important. In fact, they're critical. You cannot run mines in socially unacceptable ways. But at the bottom line, underline it, there has to be a solid business case. Just a quick run through of the chart. The red bars indicate expenditure pattern to set up the project, and this is not unrealistic. Anywhere from 4 to 6 years for a major mining project. At the end of that project phase, we get into revenue generation, indicated by the green bars. That's all about producing products to serve the global economies. At the same time, we continue to spend operating costs. And at the end of the chart, you see a large negative bar, and that's for closure. And closing up responsibly closing projects is very important and requires significant funds. I'm going to talk about what I call the NPV game. And without a solid project financing model, without solid returns, we don't produce. And the very simplest way of representing this is with the NPV calculation. There's 2 terms in here, and I'll talk a bit about those. Cash flow in any given year is critical, and then a factor to compensate for the time value of money. Money today is worth a lot more than money in the future. So cash flow management is extremely important to the industry. Cash flow is a very simple concept, revenue minus cost. We have to make money, we have to pay our bills. Whatever's left over, that is the investor's return. The term for time value of money, of course, is money sooner is better than money later. I'd rather have payment tomorrow than in 10 years. On the previous example, I've run the NPV in the chart. Actually, that project was a complete dog. It was a terrible project to invest in. It looked great. There was over $1 billion in free cash flow. The problem is it took too long to develop the project and too long to produce. A simple way to improve NPV and get mines going, improve cash flow, get money sooner. That's essentially the 2 drivers. And I want to focus on how the innovation groups, how our research organizations and partners, how our government partners and stakeholders can help us to achieve higher NPV and promote projects. On the revenue side, ore production is critical. More production is better. We need access to human capital and resources and intelligence in terms of engineers, operations, new software, new planning tools, and new equipment. Ore grade, absolutely critical. What's in the ground we can't change. How we extract it, we can manage. Very important for us to use the right techniques and methods. Anything we can do to upgrade the resource, critically important. Mineral recovery. This represents losses in the industry. No matter how we process our material, there are always losses along the way. This is really loss management. How do we extract the absolute maximum from the ore body? Metallurgists, mineralogists, chemical engineers. These are the people that will help us solve our problems in this category. Risk management, what I term certainty of operations. Again, upsets in the organizations, upsets in the cash flow. This is very bad for our investment community. And the mining industry is rife with upsets. Managing our process flows in a sustainable fashion is extremely critical. People that can help us here are technical specialists like rock mechanics, ventilation engineers, and as well as human resource managers and labor relations specialists. Very little we can do about price. Most mines are driven by commodity pricing. There's almost nothing we can do to control price, except we can make better products, better quality products, products that are more usable for our end users. So along those lines, we need research chemists, marketing agents, and customer reps. I want to briefly highlight a couple of areas in terms of cost. In terms of cost and a business plan, lower is always better. Doesn't matter if we're talking about our labor charges, how much labor we use, how efficiently we're using that labor, whether we're using energy, what choice of energy, whether it's electricity, whether it's diesel-powered generation. Substitution is a good idea. On the materials side, changing our processes, using less material. This is also very important. In these areas, we rely on cost planners, procurement specialists, electrical engineers, system designers, as well as partnerships with the supply side and partnerships with research. Also caution on the use of false economy. In the mining business, it's generally better to spend more upfront to achieve better returns long term. On the last slide here I have is a focus on time. I would say this is our greatest challenge in the industry. You heard the urgency at which Doug talked about the demand in the market globally. We need to bring a tremendous amount of supply online rapidly to service that need. We face a staggering array of government regulations and controls at all levels, be it local, regional governments, provincial governments, or federal governments. And we understand that there's a lot of pressure coming at us from NGOs, and rightly so, and also the stakeholders in our communities. Anything we can do to improve the approval process timeline is beneficial. One of the issues we talked about was the aging workforce, the lack of talent to run our projects and mines. Anything we can do to pull forward that knowledge and intellect, bring it in and apply it as fast as possible to our projects is going to help us. Development and construction time, new techniques, new methods, rapid development, boring techniques. These are all tools and innovative techniques we can use and apply to move our project timelines forward. I'll try to wrap up with a few comments. Whichever company wins the NPV game will win. They will be very, very successful. Research and innovation absolutely has to happen in the business. Absolutely. We cannot continue with the same technologies and the same techniques. Every day our mines are changing in their characteristics. They're deeper, they're lower grade, they're farther away, and we need to find innovative ways to bring those to production. Any technology that can improve the NPV of a project will be readily funded, will be fully supported by the businesses, and will be rapidly integrated and adopted. Doug did mention that there is resistance out there, and absolutely there is. But if it makes money, if it can drive the business, it will be supported. On the people side, if you are one of those individuals that can identify and implement changes that will help our business, we want you in the business, and you will be personally very successful. And this is not just engineers and scientists and technologists. This is across the board. We need financiers, we need economists, we need HR specialists, we need medical professionals, we need airline pilots, helicopter pilots. The full supply chain needs to be staffed up. I'll close with a few comments. First of all, a quote from someone with tremendous vision and drive. There is no future except what we make. The future is not a random occurrence. The future is designed and engineered to be what we want it to be. As leaders in the industry, this is the work that we're expected to do. We add value to the economies of the planet through mining, and we improve the lot of each and every person on the planet. In my opinion, this is a great adventure that we're on, and I encourage anyone in the audience today who's not explored the mineral industry to please come forward at the end, talk to any one of us in the business, and we'll tell you what an exciting ride it is. And I thank you very much for the opportunity today.
I'm going to use this microphone here. And I've got a laser pointer, so you know that I'm an academic here. My name is Ramesh. I would like to thank everybody present here and the organizers for giving an opportunity. So I'm going to talk a little bit from the academic side in terms of the HQP for the mining industry, but for industry in general. I'm not going to apologize. I'm a chemical engineer. I'm not a mining engineer. I'm a chemical engineer. Okay, so I think Doug mentioned, and even Brian mentioned there, one of the problems we're going to have is the next, oops, this doesn't work. In the next 10 years, if you look at the average age in the mining industry is 55. So what do we do in the next 10 years when there's going to be a huge vacuum on the supply side of the people entering the market? And Christine mentions, I've mentioned some of the industries related to the mining industry here, but there's also the social sciences, the Aboriginal issues, those need to be taken care of. And the HQP actually starts at the post-secondary institutions. In fact, I would argue in my presentation, I would say that it actually starts at high school level. I mean, really, you've got to start getting people involved in engineering that early. Just to give you an idea, I'm not sure how much you can see this part here, but this was in the Maclean's magazine in September last year. And if you look, actually the mining industry has done fantastic in terms of doubling the numbers. These are the graduate students at the undergraduate level in Canadian universities. It's more than doubled. But so has, if you look at chemical engineering, the numbers have gone up, civil engineering numbers have gone up, and that's the big pie chart there. And you can see mechanical, civil, the industries that are more related to the mining engineering there. The mining is actually, I'm not sure you can even see it's way over there, okay? Now, I'm not expecting this whole thing to flip around with mining becoming mechanical engineering, no, but we have an issue. And my talk would essentially, one of the untapped market right now we have are the female engineering students. If you look at across universities in Canada, for me the problem is the disappointing number is, I see that over the years the numbers have actually dropped. The enrollment numbers have increased in Canadian universities in engineering. But this is where we've got a huge resource and we really have to tap this market. It's going down to 18%. And I think that's where we really, really need to be concentrating in the next, I know in the next 10 years, you're gonna have a huge vacuum in there. And if you look at the programs, the big programs like mechanical engineering, mining engineering, it's anywhere from 10 to 15%, really. We really have to get the message across, especially to the girls. And I'll show you some of the success stories, especially at Laurentian, what we have done over the last 6-7 years. Our numbers have gone up 6 times. So if you look at some of the chemical side is doing pretty okay. It's about 30%. But if you look at in the last few years, starting from 2007 to 2011, actually the numbers are starting to drop, okay? I go to a lot of science fairs. I judge science fairs. We just had one in Sudbury Regional Science Fair. The good thing is, out of the 7 participants who are going to the National Science Fair, 6 of them were girls. This is amazing this year. This is the first time I've seen that. But my worry is I don't find a lot of entries. In fact, no entries in the junior or the senior engineering category. And this is disappointing, okay? So we really need to get the message across there. Even though the overall numbers, if you look in here, of the students at the university in engineering has increased, the percentage of women actually has started to drop. I don't know what it is. I mean, one of the things I was looking at is maybe they're not cool enough shows on TV about engineering. I mean, you see CSI, and suddenly at Laurentian, our forensic science program numbers have just gone through the roof there. They can't handle more than 40 students, but the applicants have just gone completely through the roof. You know, lawyers, there are fancy TV shows about lawyers, same thing with doctors. There's nothing about engineers. I mean, yes, if you watch TLC and Discovery channels, occasionally they have the mighty ships and everything else, but it's not exactly appealing to the kids. And this is the other telltale sign. If you look at them, all the heavy programs here, the mechanical, electrical, there's actually a significant drop. That's the line you see in dark in the center. And you see a significant drop in the enrollment. I think this is a really untapped market. This is exactly what we need to do and get the message across in schools. And I've just I've just written the number of mining schools in Canada. There are 10 of them, 3 in Ontario, 3 in Quebec, 3 west, and 1 in the east. And this is by the province. Again, if you look at the female undergraduate numbers, you can start to see the bigger ones, Ontario and Quebec. And in fact, you look, the numbers are not exactly nice. It's disappointing. I mean, this is where the big universities, Ontario's got, I come to the university fair every year in September or October here. You have 20 universities, I think 16 or 17 of them in engineering. the numbers are a little appalling, actually. And this is just from a licensing engineering point of view once they get their engineering degree. Okay, and postgraduate, it's the same story. If you look in there, postgraduate enrollment in Canada, if you look at the numbers, right now we're actually, the market is pretty good. I wouldn't lie. I mean, the job market is so fantastic. We're really having trouble getting students to come back into graduate school, okay? Now, this may not affect the job market really, but one thing you have to understand is even just like the industry, the university people are approaching. In fact, there are some university professors over 65, not retiring, and I think one of these days, you know, they're going to start dropping dead in classes. That's just my opinion, okay? Then what's going to happen? We're really worried. You know, we need highly qualified personnel in academia too, okay? I mean, the deans of any university would tell you, this is a problem. People are not retiring, but they're going to drop dead sometime, okay? So again, the postgraduate enrollment by gender, if you look, it's about 21% for females. It's a little bit better than the undergraduate level, but the numbers are not that high. One of the quick plug I have for Laurentian universities, we started the School of Mines primarily in response to this ring of fire. And if most of you know, the School of Mines is going to be not just taking care of the engineering and the geology and the science side of it, but more of the Aboriginal issues, some of the management issues associated with it. This is my last slide. Actually, the key, I think, is outreach. Okay? Get them young. I never liked Joe Camel for what he was endorsing, cigarettes, but the message is get them young. Okay? Start going to schools. In fact, we have started going to schools at the 10th, 11th, and 12th grade and talking to the students there to get into engineering. I talk to them engineering as a profession and various disciplines of engineering. And we have a Go Eng Girl event, which is essentially for 7th to 10th grade girls in schools. Get them interested in science and engineering. You're not going to expect them to turn around and start enrolling in engineering programs if you don't talk to them at high school level or even middle school, okay? And the other thing I've seen some of the universities do right now is to tweak their mining program or mechanical or chemical programs to have elements related to either the mining side, the processing side, really, in the program. And this definitely is, I'm not saying it's going to really address the issue, but start to address the issue of the shortage of HQPs. Just to give you an idea, I told you that our Laurentian, our numbers in the last 6 years, if you look at them from 2006, when we really started to go out to different schools, talking to students, our enrollment numbers actually went through the roof from 2006, from 67, we've gone up 6 times already. I know it works. The question is, are we willing to put the time? And I think the mining industry should be actually putting resources in there for the universities to go out and reach the kids. I mean, at the end, in 10 years, you've got to address this issue. Get more students into engineering. And even if a small fraction actually ends up in the mining industry workforce, it'll be great. Thank you.
I want to thank Doug for the opportunity to speak to you today on this topic of towards low carbon mining. At the same time that you have this huge growth in demand from the mining industry, you have another major pressure, and this is coming from climate change and the need to reduce the carbon emissions from or associated with mineral production. So that's really what I'm going to talk about to you today. This graphic is a Sankey diagram, something that shows the flow of energy of different forms from where they cross the fence into a mineral production process to the actual cost center areas that in which they're consumed. The point I want to make in this slide is that the red lines represent the electricity. Everything else is essentially fuel, and the fuel really is used for heat. So the point I want to make in this particular slide is that we shouldn't just get preoccupied about electricity when we're thinking about the energy required to support mineral production. For underground mines, there's a sort of inevitability. And Doug mentioned this. He said that as mines get deeper, so they tend to consume more. In fact, this graph here shows the energy consumed per ton of ore mined or processed going through a processing plant for a gold operation. This is data. It's available in the public domain. It's for Musselwhite Mine, which is located in the far north of Ontario. The green line shows all different forms of energy being consumed, and you'll see that over the past, since 2001 through to 2009, the amount of energy per ton has been increasing, and that's because the mine has been getting deeper. We need more energy to win the rock and bring it to surface. So this doesn't really paint a very good picture for what is actually a very progressively run mineral operation. It doesn't reflect the efforts of the engineers at Musselwhite Mine that really reflect a situation of continuous improvement. It's only when you take into account the depth factor of mining as well that the true picture emerges. Over the same period of time, once we measure the energy consumed, taking account of the depth, you can see that the engineers at Musselwhite Mine have actually been doing a really good job. Significant reduction as a proportion of the total energy consumed. So one could argue that it might be appropriate for Musselwhite Mine to adopt one of these new voluntary standards that aim to recognise striving for continuous improvement in energy management associated with mineral production. The standard that came out last June, which really took everybody by surprise, was ISO 50001. So despite the fact that energy consumed is increasing year on year, this mining company is still striving for continuous improvement to lower the energy consumed and therefore lower the cost. The cost, as Brian sort of suggested a bit earlier, it can be quite significant for mining companies. Maybe 40% of total operating costs can be attributable to energy costs. So after labour, the next thing that you can do or deal with in running your operation is actually sort out the energy usage. There are loads of wonderful applications of renewable energy technologies that are present within this conference. And my personal mission is to try and make sure that as much of that new energy management, energy efficiency and renewable energy technology makes its way into the mining industry to reflect this striving for continuous improvement. Although it's a voluntary standard, there could be I believe that this will be actually a market-driven transformation for the mining industry because of the proportion of operating costs which are attributable to energy. So as an investor looking at investing in a mining company, if you know that a mining operation is ISO 50001 accredited, then it's it's striving for continuously improvement in energy consumption, really analogous to striving for continuous lowering of operating costs. Where are you going to put your money? So although it's a voluntary standard, I believe it actually will have some real market-driven teeth. Another thing that we can do, nobody can read this slide, but it's what it represents that's important rather than what the words say. It is a screenshot of a database of best practice examples of energy-saving technologies, specifically coming from the mining industry, the Australian mining industry. You can see, listing the first 5, there are 254 additional examples in this database, which, through our work at Morocco, we are trying to encourage mining club entities to look at, to see if we can disseminate best practice as identified in other jurisdictions and bring these to Ontario as well. But we're not only doing that. In fact, Canadian mining industry is actually really very innovative in its own right. And so at Morocco, we're starting to build up our own Canadian database of best practice examples of energy management practice in the minerals industry so that we can promote this and encourage wider adoption. One example drawn from the database shows that the mining industry has long been aware of the amount of energy it uses and has long applied innovative approaches to tackle them. So this one here is Raglan mine, not in Ontario, but in Quebec. And this mine was created in 2001, and what they did was essentially recover the heat that was released when diesel was burnt in a diesel engine to produce electricity, and use that heat to dry the concentrate product that was produced at the back end of the mineral production process. And in doing so, they reduced the energy cost to 50% of what they would have otherwise have been. In these remote areas, as I think Christine and Doug both highlighted, the cost of energy is a lot higher than in grid-connected or places close to energy infrastructure. So this is a great example, but does highlight that perhaps the problem is encouraging wider adoption. There are some I'm going to close my talk by talking about some what I call disruptive technologies that may make Brian think in a different way about the cost structures associated with energy for his operations. This graphic here shows a wind turbine being used not to produce electricity, but being used to produce liquid air. The liquid air is stored in a cryogenic tank, and then, when required, is delivered down a borehole 2 or 3 kilometers deep, where it's very hot. The liquid air is then allowed to evaporate. As it evaporates, it cools the environment in which the miners have to work and in which the equipment has to work as well. So this is quite an exciting, potentially disruptive technology, which promises to provide not only low-cost cooling for mines, but also low-carbon cooling for mines, therefore hitting both of those issues I mentioned at the beginning of my talk. Another example, some of you may have visited the Morocco stand earlier on today or yesterday. You may have stood on this very panel in the photograph here, which is a photovoltaic panel. It floats and it produces electricity. So we see the application areas as freshwater lakes. The materials are marinized so they'll be suited for the sea as well. And then also they would be suited for tailings impoundments, which have additional benefit of security around them. And so again, as well as solving a sort of tailings coverage problem, tailings dam coverage problem, they also have the benefit of producing electricity, which ultimately would lower the energy and carbon intensity of the minerals being produced. Third technology, again, not really getting very good rendering here, so you can just see a matrix of pluses and minus. If you're lucky at the front, at the back, you wouldn't stand much chance. But what this represents is the fact that at Morocco, we are working on optimization technologies that take into account the conventional electricity generating systems, such as diesel engines, gas turbines, and so on, together with renewable energy technologies of different types, with their specific characteristics, intermittency and variability. That means we're never going to get away from using the two technologies together. Renewables technologies and the conventional technologies will need to operate together. We've shown in a study that we conducted for the Ring of Fire area that using a floating photovoltaic technology in tandem in an integrated, holistic way with conventional diesel generation would lower the overall cost, or would lower the discounted cost of electricity produced to a mine user by 10%. So we lower the electricity or the specific energy consumed, we lower the carbon emissions, we save cost. starting to sound good. So I'm going to leave you with this summary slide. What I've said is that maybe energy certification schemes like ISO 50001 could be real drivers for continuous improvement in energy reduction, carbon emissions reduction, and improvement in cost for mining companies. I think there's a need for disseminating of best practice throughout the mining industry, so doing what the mining industry has already proved to be good things in certain locations and rolling those out into others. And then for industry, and it's great to hear some of the comments that Brian made a bit earlier about perhaps demonstration projects to try and bring these new technologies on, as well as a need for industry to invest in R&D that will make some of these disruptive technologies and ideas a reality. Thanks very much.
Thank you. I hope some of you have some questions. I know Christine is going to have to slip away in a few minutes. So if you have any particular questions about the Ring of Fire, perhaps you could ask her first. You have a question? Yep.
My question is related to energy usage and the Ring of Fire. Is there an intention to have any transmission or to bring the grid to any parts of the Ring of Fire? For example, to the reprocessing facility closer to Sudbury or to the actual mine location, or will it all be remote from the grid?
In terms of the processing facility located just north of Sudbury, there's already existing transmission and capacity in that area. In terms of the remote far north, which is, I think, where the question would be more applicable, at this point, there's no firm plans. As I'd mentioned, the companies are both proposing to generate electricity by diesel to run their operations. All the communities within that region and across the entire far north are powered by diesel generation. So I think in the broader context, there could be some opportunity to look more broadly at alternative energy sources, but that's not currently part of the specific project design right now.
I'm over here. I wonder if the mining industry has ever considered using canals as a mechanism to transport material to and from a mine, or even, a frozen canal can be a road in the winter, and it can be a bargeable, heavy-duty transportation system in the summer, and it's pretty low-lying and wet all the way through northern Ontario up to James Bay.
The issue there is simply the creation of the canal. In actual fact, in the far north, there are very, very large rivers that are actually, most of them, amenable to that kind of technology, but only for a few months of the year. So what you require then is a technology that works throughout the season to move material from one place to the next. But the digging of a canal in the far north would be difficult, but there are some very, very large rivers that make it possible. So yes, it's one of the things that's being considered, I think. Just waiting for another question, just in case anybody's interested to know. Roughly across Canada right now, there are about 10,000 open positions in the mining industry. So if you know anybody who's looking for a job, we have some. Yep.
Leon Wasser from Canada-Israel Technology Exchange. We are looking at bringing some Israeli technologies which have been globally applied to Canada. And specifically, we see opportunities, and we've had discussions with both First Nations and with government officials and politicians of introducing a wide variety of technologies into the north that could serve both the existing First Nation communities, the fly-in communities, and those that are road and rail connected, but also the developing mining facilities that are going to be emerging throughout the north, both in Ring of Fire, but also in other areas of the north. And the technologies that we're looking at range from water remediation, including heavy metal extraction and recovery, and rare earth extraction and recovery, and renewable energy, to address the comment that was just made about the existing situation, which has 21 flying communities which are completely dependent on flown-in diesel at $40 a liter, replacing those with a combination of solar, wind, micro-turbine generation capacity, but also the opportunity for fish farming in the remote north, and agriculture, both greenhouse agriculture on the surface. But one of the things that came out of a recent meeting was the opportunity to use mines. And as we all know, the further we go into the earth, the warmer it is, and provides an opportunity to actually grow vegetables. And everybody that's been to the Big Nickel knows that they have experimental greenhouses there. So I'm wondering if there's a mechanism in place to introduce these type of technologies on a collaborative basis, both for the mining sector, PDAC and its members, but also for the First Nations that have been there for thousands of years, of course.
Yeah, there certainly is. We're happy to try and take any of those forward. We have some people working on some of those things already. There are fish farms in the near north. There are no fish farms in the far north. But some of the advantages of fish farms in the far north are that the lakes are completely isolated. So unlike other facilities where there's connectivity between large populations of fish for transmission of disease, that's not the case in a completely isolated situation. So that can be sequestered in that way. So there are lots of opportunities for all of those things. Happy to hear any of them, or all of them.
And we're looking forward to working with you as
Okay.
well.
Anything else? I think we're running close to the end of our time, but we're happy to stay on if anybody has more questions. We'll stay. Just there are other events happening that you may want to go to. Yep, please.
Is there any preferred technology for the mining for water processing?
Preferred in what sense?
With respect to environmental
No.
environmental impact?
No. If it solves the problems that we have, we're interested in using it. Nobody else? No other questions? Well, simply remains to thank the panel for coming and giving their presentations, and thank you all for coming. Thank you.